Hey everyone, I'm just gonna do a couple of, or a slight review on doing parallel line with tees. So if you can see here, I have a 4-inch round piece of pipe teeing into a 6-inch round piece of pipe. It's 4 inches long, and I've put the seam on the long side here. Typically it would be on the short side. I just wanted to show how this would look if the seam was on the longer side. But most of the time you're gonna have the seam on the short side. So first step is to make an end elevation view. So I did a half profile of the 6-inch pipe here because I don't need the full one. I came up the 4 inches off the center for the height and then made the 4 inches across and did a profile on top. Now if you notice, this half here is the same as that half there. So I didn't really even need to draw this entire end profile or end elevation view. I could have got away with just a half of it. But just for the purpose of this video, I wanted to show you the full one. So once I've drawn that T in the profile, I divided it into the equal spaces. If you remember, if I had this as the radius here, use my radius to swing the arc, and then use that radius off the center to make those divisions, and then off either end to make those divisions there. So once I've divided in 12 equal spaces, I drew those lines back down to the base pipe here. Now that turns these lengths into true lengths, right? So from this point here down to here, from here down, all those lengths there where they actually hit the 6-inch pipe becomes a true length. So then I did my stretch out of the 4-inch pipe for the T, just 4 times pi, and divided it into 12 equal spaces. And I did that by putting my ruler on an angle to find 12 equal spaces in there. And then just simply moved these dimensions over here. So I just took the length of number 1, and that was my seam on either end. Now number 7 is also the same length there, so that was number 7. And then I went to number 2. Now 2 shares the same line as 12, and then on this side here, they also are the same length. So 2, 12, 6, and 8 are all that dimension, 2, 6, 8, 12. And then the same with 3. The height of 3 does 3, 11, 5, and 9. And then 4 and 10 are the last two. And once you plot those lengths over, then you just draw a line, and that's the profile of your T. Shop instruction would be roll 360. And I have no seam allowances on this one. If there was a seam allowance, like a groove seam or whatever, I'd add that on to the end of that stretch out. I also showed an equal diameter T. So this one, there's a bit of a shortcut to it. So this is a 5-inch round on a 5-inch round pipe. So I did the same thing. I did a 5-inch round half profile here, did the T height, and then I did a profile on it. The thing with when you have equal diameter, this profile here is exactly the same as this one. So if I did all this work and put these lines and brought down where it meets this pipe here, it's the same as if I just took that profile and divided it into equal spaces. So I actually don't even need to draw any of this. I can just take this radius here of the 5-inch pipe, and I have my stretch out of the pipe, so 5 times pi. If I just take that profile or the radius and draw a circle on this end, divide it into equal spaces, and do the same on this end, divide it in equal spaces. And then if I draw lines connecting those, 1, 2, 3, and make sure you don't forget the very top of the circle. The very bottom of the circle is also going to be technically a line. Then it's just a matter of starting at the highest point where the seam would be. In this case, the seam is on the short side. So the seam is on the short side here. It's just a matter of following these green lines I put, starting here, over one, down one, make a mark, over one, down one, make a mark, over one, down one, make a mark, and then when I'm at the bottom, then I just go back up again. Over one, up one, over one, up one, over one, up one, till I'm at the top, and then all the way back down, and then back up until you're at that seam again. And then that profile ends up being the pattern for this one. So again, roll 360. And no seam allowances again on that one. The last one I wanted to show you, well, actually before I move on to the last one, this, for either one of these two, any tee that's 90 degrees, so if this one was flat on top or flat on bottom, if it said FOT or FOB, I would need to draw this end elevation, and if it was flat on one side, I wouldn't have this coming off the center of the pipe. I'd move the whole tee over till it's flat on the one side, and then do the same thing. And then wherever when you divide that upper profile and those lines come and hit this pipe here, that's gonna determine how your pattern works out here. So any 90-degree tee, just an end elevation view is all you need. Or if it's an equal diameter, all you really need is half the profile, or a quarter circle actually, to lay out the pattern. Now, if it's on an angle like this, I don't have enough room to do the whole stretch out here, but I just wanted to go over the process of defining your true lengths. So here we have a 4-inch tee going onto a 6-inch round pipe. The tee's at a 45-degree angle, and the inside length here is going to be 3 inches. I need 2 views to actually get true lengths here. If I took that angled tee and turned it to an end elevation, which I have here, there's no true length on it because this whole thing's leaning down towards me. So these lines are not going to be true lengths. So I have to develop true lengths from the side elevation. So I basically need to draw both elevations to be able to get these true lengths here. So I have to lay out a miter line. So with the end elevation here, I just used half of the 6-inch pipe profile. I went up just an arbitrary length. This could have been shorter, it could have been longer, doesn't really matter. I'm trying to do is get these points here where the tee touches the 6-inch pipe. So I just did a random length, did a quarter profile of the 4-inch pipe, did the equal divisions, brought them down to where they hit this 6-inch pipe, and then I transferred those lines across. Then I did a side elevation view of the pipe. I did half of the 6-inch pipe here, 45 degrees, made my 4-inch pipe with 3 inches here. Did a profile on the top, divided in equal spaces, brought those lines down, and wherever these lines intersect these lines, that's where I put a dot. So again, starting right at the crotch, I went over one, down one, over one, down one, over one, down one, till I was at the lowest point, over one, up one, over one, up one, over one, up one. So, and then that gives me a profile. And then if I had my stretch out laid out, I would take each one of these lengths, probably starting at the inside crotch, because that's most likely where the seam would be. But that is a true length, and I'll transfer that to my stretch out. And then that one, etc., right? In all the appropriate spots. I know this is not perfect, but this is hopefully just a review for tee layout. I'm going to be making another video shortly showing a tee on a taper. So that one there is a lot more complicated, but this should at least warm me up to the whole idea of parallel line.